Hello and welcome to Circle Theorem 6, which is called the intersecting chords theorem, and it's the main circle theorem about lengths that you need to know, and it's about two chords that intersect. So here's a chord. A chord is any line that joins 2 points on a curve, in this case the circle, and here's another chord that intersects it. Just note they don't have to be diameters or anything like that. Okay. Now I'm going to call the first chord, this chord here, AB, and I'm going to call the second chord C to D, and I'm going to call the point where they cross X. Just notice that the order going around the circle isn't the conventional one, because the first chord is AB, so you do that, so you don't get ABC, you get ACB. But in any case, the theorem is very simple. It says that the length from the circle to the crossing point, AX, times the circle to the crossing point on the same chord, BX, other circle point, is the same on this chord as it is on that chord, so it's equal to circle to crossing point times circle to crossing point, CX times DX. And actually I strongly recommend that you don't try and learn this formula, because someone will come up and trick you by labelling the points incorrectly. What I recommend you learn is you learn the slogan circle to crossing point, or circle to crossing, times circle to crossing, equals circle to crossing times circle to crossing. Okay. Now you've just got to remember a few things with this slogan. It has to be circle to crossing times circle to crossing on the same line. And obviously the reason there are two of them is because there are two different points on the circle, so two different lengths from the circle to the crossing. AX and BX on the one line, CX and DX on the other. That is the intersecting chords theorem. I've called it intersecting chords theorem A because this is the case where the chords intersect inside the circle. And we'll just do an example. Here we go. Okay, let's call that 6 and that 8 and that 3 and that A. Okay. So suppose you've got to find the length A, where A is this length from here to here. Notice I'm not going to label the points. I'm just going to use the slogan, which says, looking at the first chord, circle to crossing point, that length is 8, times 3, circle to crossing point, is equal to 6, times A, circle to crossing point, times circle to crossing point, and that's quite an easy equation to solve. 24 equals 6A, and A equals 4. Of course, I will prove this theorem in another video. I'm just going to do one more slightly trickier example. So here's a circle again. Okay, that chord looks a bit like a diameter, but it doesn't need to be. The centre of the circle doesn't need to be on it. I will label them this time. I'll call that one A, B, and that one C, D. And I'll say we're given the following information. We're given the fact that, let's say, AB equals 11, and let's call that X, shall we, like I did. AX equals 6. Yeah, and that DX is equal to 8. Find CD. Now, the annoying thing about this question, what makes this question hard, is they've given you not quite all the information you want to do. Circle the crossing point times circle the crossing point. They've told you AX is 6, which is useful. I'd mark that on immediately. But they haven't told you what BX is. They've told you what AB is. It's not difficult. You have to do the subtraction and get that it's 5, but it's easy to miss and to assume they've given you the two lengths that you want. So just look out for that. They've also told you that's 8, and they want you to find CD, but unfortunately, the intersecting chords theorem isn't so good at finding the total length of the chord. It's good at finding the circle to the crossing point. So we're going to find that, and I'm going to call that x. Once we've found x, then to answer the question, we'll have to do this length plus x. But let's find x. Shouldn't be too bad. Using the slogan or the formula, circle to crossing point times circle to crossing point on one chord is equal to circle to crossing point times circle to crossing point. That's 8x on the other chord. So you actually get x equals, dividing both sides by 8, 30 over 8, which is 15 over 4, which rather frustratingly doesn't cancel any further. So that's just it. It's a fraction. Life is tough. And then finally, CD is equal to 8 plus x, which is 8 plus 15 over 4. And of course, we would never leave it in that form. We'd go for a top-heavy fraction. So that's 32 over 4 plus 15 over 4. And I should write this on the next line, but I'm out of space, so I'll naughtily put a second equals and go for 47 over 4. And that's the best way of leaving the answer in that top-heavy fraction. If you want to write it as 11 3/4, I guess it's okay, but my preference is leave it as the top-heavy fraction. There you are.